Hi everyone, I'm George Hantzaras and I'm here to talk to you today about our journey to improving SLOs and the role that Vault has played in this journey. I'm part of Citrix's cloud platform engineering organization, and there I work with the teams that are building the new observability platform and also the teams that are building secret management infrastructure. And also I'm a huge fan of HashiCorp products. Earlier this year, I became the organizer of the Athens HashiCorp user group. Today we're gonna go over a presentation. It's in two parts. The first part goes over our implementation journey of observability and the role that Vault has played in this journey. And the second part is gonna move a bit away from observability, and we're gonna get a bit deeper in secret management and go into the details of how secret management played a role in improving our SLIs. Finally, we're gonna see the lessons we've learned through this process and what the future holds. So the reason this is important for Citrix is that Citrix is a driver of change due to the nature of our products. As we transition to the cloud, we at the same time we drive digital transformation for our clients. So when we're talking about this transition or any kind of transformation, perceptions are important. It is important for our customers to trust that their service is going to be equally or even more reliable, available, and secure than the on-premise offering. With that in mind, all the observability efforts and the security efforts should always encompass this customer centricity. Now, going a bit into the observability and to our observability mission, our mission describes two goals. One is to provide better product insights for the engineering teams, and the second is to optimize incident response. And both these goals are there for one specific need: to improve customer experience. And this is probably the key takeaway from today. Observability nowadays should be customer centric. Now, the requirements when we started our observability journey were five. One, real-time insights. Be able to provide customer support teams, engineering teams, SREs, be able to provide a real-time view of what's happening, be able to provide real-time tracking of our SLOs. We wanted the observability platform to be self-service. This means reducing the overhead of anyone onboarding the observability platform and automating this process. A third part, we wanted the alerting to be configurable, being able to use multiple channels, multiple platforms in order to communicate and alert. The fourth point was the integration. So coming into a mature organizations, we wanted the observability platform to be able to plug in with many different monitoring platforms that were already in place and be able to integrate with different data sources that are already in place within the organization. And finally, we wanted to roll out a new SLO framework that describes this customer centricity and operationalizes error budgets and puts them in our everyday development life. And this is pretty much what we've ended up with. This is how observability looks like. So starting from the bottom left, we see this multitude of applications, different deployment methods, different types of infrastructures, and we wanted to be able to address these needs. And there's where the top left component comes in place, which is the ingestion layer. And there's where you can do filtering, rate limiting, and you can power this with open source tools like Kafka or with SaaS tools like Cribble. And then finally, the blue box in the middle, this is the first important part. This is the metrics storage. And again, as we started and we wanted to serve a mature organization of 2,800 engineers, a key component was being able to serve different data sources, different platforms that were already in place. And then moving further to the right, the core observability platform component is our observability API. This is where data from different sources come together, and they are aggregated, they are correlated with customer data, and then finally error budget and SLIs and SLOs are calculated, and finally we provide the interfaces for the dashboards to be implemented for the SLOs, customer impact, and customer user journey uptimes. Now, we went with the observability as code approach because we wanted first of all, two components on the onboarding, self-service onboarding, which was GitOps and Zero Trust, to enable the self-service aspect of the observability. And then we wanted metrics as code, dashboard as code, and finally alerting as code in order to reduce the implementation time for the product teams, but also to be able to promote best practices across the organization. So now the reason we selected the observability as code is exactly that. So first of all, faster implementation across product teams. We created reusable assets, which reduced the time to onboard for product teams. With the reusable assets, we ended up with reusable best practices. Coded in, built in our toolset. And then finally, this Git-driven approach provide versioning and automation for metrics and alerting and so on. Now this is how the observability deployment pipeline looks like today. So it starts with the engineer cloning the repository, creating simple configuration files, and then just opening a pull request. This pull request then triggers the build pipeline, which creates the final Terraform modules, the necessary configurations, and so on. Then the testing pipeline is configured from static analysis, integration test with linting, Terra test, and so on. And then finally, the assets are deployed in staging, published in Artifactory, and ready to use in production. Now, the role that Vault plays in this whole process, first and foremost, it enables zero trust on the deploy time. So custom secret engines can be developed by everyone. Secret engines provide a way to manage secrets for different services, and that way we can manage API keys and access keys for the different monitoring platforms like New Relic, Splunk, Datadog, Elastic, Prometheus, and so on. The second part is it enables our synthetic monitoring to be more secure. So synthetic monitoring can use passwords, can use API keys, and all these are managed through Vault. And finally, the access to our observability API from the dashboards, from the CI/CD pipelines, and so on. This again is managed by API access keys managed by Vault. Now, this is pretty much what the deployment looks like after Vault comes in place. So we have, as we said, it starts with Git workflow. Then the build is triggered where testing and templating takes place. Then finally, the artifacts are published, the metadata is stored. And then when the deployment starts, Vault takes over, and that's the part where the deployment pipeline requests the credentials from Vault, and Vault creates the dynamic API keys to the different metrics providers. Now let's go a bit deeper into the code. Let's see some observability as code examples. We're gonna start with this example. It's with Terraform and New Relic. So at the left, we see an example of dashboard as code, and here we see a New Relic dashboard with multiple widgets being created, and specifically one widget shows the HTTP response codes that are not 200s, and we're using a New Relic, an NRQL query for that. Now the middle and the right examples show an alerting as code example. On the middle one, we see an alert policy, So again, we define an NRQL query and some conditions. These can be multiple. Here we just have the critical one where we set some thresholds, and at this point we want an alert to be raised. And finally, on the right one, we see the communication, the notification channel being configured and associated. So this email channel is going to be used when the alert condition in the middle is being violated. And this is great because it covers a lot of the needs we saw earlier. So one is it's reusable, it's versioned, and it's testable. So this is good. But again, this is a Terraform script. So this means that the product engineers should understand how HCL works and should be able to write that. So in order to operationalize this, we need to go one step further. So here we see the alert, the condition alert example again, but then on the left and the middle, we see that all the thresholds and the NRQL query have become just variables. And then on the right, what we see is that we just have a YAML file, which we require, and the NRQL query and the threshold are put in the configuration file. And then the CI takes over and puts this all together, and it creates this alert in New Relic. And this is how we end up with something that is truly reusable. So the middle and the left part is something that can be used from all the teams, just changing the YAML definition file at the left. And this can happen with metrics, dashboards, alerts, and even SLOs. So this is an SLO example, and for defining SLOs as code, there have been a few really good projects lately, open source project. The most significant one being the Open SLO specification, which we can see here. And here what we see is we define an SLO which is latency based, and we define it in Prometheus with a Prometheus query. And we want this to be greater than 99%. So 2 nines is the SLO defined here. And in the bottom we can see that this is on a monthly window, which is non-rolling. And again, looking a bit deeper here, these are stuff that are kind of standardized across the company. So the only thing that would change would be the SLO target and the PromQL query. So again, this can be templated with a YAML file, which would be really easy for a team to define. So we kind of saw how we can move from dashboards as code to alerts as code, and now SLOs as code. And the last example I want to show is how the next step looks for us, and this is how we visualize SLO today. So this is our new SLO dashboard mockups. And of course, you see all the metrics that you would expect to see in an SLO dashboard. SLIs, error budgets, number of incidents, and so on. Where I want to focus is a bit on the top right part, where you can actually see number of impacted customers. And there you can drill down a bit even deeper, and you can see per incident impact per customer, and you can measure specific uptime for user journeys per customer. And again, I want to focus there because I want to show you that observability should be customer-centric today. Now, moving a bit away of observability, I want to see a specific use case, a use case on how secret management and secret rotation played a significant role in our SLOs, and what impact we were able to make just by automating this management. So when a customer launches a virtual app or a Citrix virtual desktop, we have 4 or 5 different services coming together in order to deliver this experience. Just one of those 5 services is the Citrix Cloud Platform. And the Citrix Cloud Platform is what enables us to deliver SaaS products. So this platform is comprised of roughly 135 microservices, and at any given point we have about 500 to 1,000 secrets stored per environment. That can be database credentials, API keys, and so on. So imagine the number of secrets stored across all the services in order to deliver the end-to-end desktop launch experience. So in order to manage that, we decided to use Vault. So this is pretty much how we have deployed Vault. So we have deployed Vault on a high availability mode within a VPN, and access is restricted only via Azure private link. Of course, in the background we have other DR mechanisms as well, offsite storage and so on, offsite backups and so on. And on the right, we have the way infrastructure as code deploys Vault, and also how the observability as code is part of this pipeline. So in the first step, we see Packer is used in order to build Azure VM images. On the second part, we have Ansible that during this build installs the required software. One of this is the New Relic agents, which is installed and configured in build time via Ansible. Then the build image is published, and then the final step is Terraform takes over in order to deploy VM scale sets with the previously built image. So again, we see here how observability as code is built in the infrastructure as code. And this is how new services are onboarded in Vault. So first we start with the team that wants to be onboarded. A repository is cloned, a new branch is created, and then a pull request is opened that contains the configuration files for this new service. Then after this is merged, the automation is triggered, and Vault namespaces are created, and access to the VNet is granted for the new product tenant. Now a little spoiler here. As I said, a lot of the stuff we're doing are work in progress. So this is 0.5% true at the moment. The other half is manual and work in progress. Now again, I talked about Vault's impact on the SLO and secret management impact to the SLO. So let's see a bit about that. So the cost of secret management for us annually is about, only for the service, is about 250 to 300 human days, manually managing secrets, rotating them, and so on. This means that automating this process gives you back about an engineer and a half to work on roadmap work, feature work, things that are going to make a direct impact to the customer. And finally, the most important thing we found about our SLOs was that around 20% of our incidents were related to manually managing secrets. Just by rolling out Vault, you are able to eliminate that. Now, moving forward, what the future holds for us for this observability journey. Going a bit what we talked about today, what we have rolled out today. So first of all, the observability API, the core platform where data is aggregated, correlated with customer data, and then error budgets and SLIs are calculated, and all the dashboards are created. The second part, the dashboard creation, reporting the SLOs, and actually providing insight to the product teams, to the leadership, and so on. And of course, this is significantly powered by synthetic testing, simulating user experience in order to measure the user impact. And finally, observability code. The first part of observability code, since it's a big journey, we have started with alerting as code. This has been working for quite some time now. What we've learned up to now, I have 3 important takeaways. So first, on-call is different than the reporting. And what I mean with that is that when you implement monitoring and alerting for reporting, it's a totally different use case and totally different requirements from when you use it for SRE usage and operation team usage. So you have to have these 2 different set of requirements in mind. And there's no one size fits all for you to address both at the same time. The second is something that I've mentioned a lot today, is customer-focused observability. This means that everything you do, you should have in mind and measuring customer impact. Sometimes the service might be up, but the customer experience might be degraded. And finally, you should start somewhere. Observability is not a project that's going to run 2 or 3 months and then you're going to be done. Observability is a big journey, and you have to map it out to see what the low-hanging fruits are for your organization, and try to start somewhere and have a continuous improvement mindset in mind. Now, what the future holds, as we said, customer impact is really important, so we have to focus more and improve customer impact measurement, being able to know exactly what our customers one by one are experiencing and how they are experiencing our services, rolling out more assets of observability as code. As I said, we've been using alerting as code, but we also want to roll out metrics as code, dashboard as code, and partially SLOs as code is now being rolled out. Third part, performance SLOs. As I mentioned during the previous slide, services might be up, a service might be available, but the experience might be highly degraded. So as we saw in the Prometheus dashboard before, a latency SLO where you measure what the customer is experiencing rather than if a service or a user journey is up. Rolling that out is also important. And finally, putting it all together, putting the CI/CD together with the observability, being able to measure the impact of a change in production, being able to use error budget in deploy time. These are the important next steps.